which is a very, very simple example. Let us read it through and see this proof. That given that alpha and beta are the roots of the equation x squared plus px plus q is equal to 0, then they are telling us to express alpha minus beta squared brackets into beta minus alpha squared in terms of p and q. Then deduce that for one root to be the square of another, p cubed minus 3pq plus q squared plus q is equal to 0 must hold. Let us go and see. It's just application of the knowledge which we got. Which knowledge did we get? We got that the sum of roots are equivalent to negative b over a. Product of roots are equivalent to c over a. That's what we know. So let us go and see in our solution, Mr. Examiner, sir. So this is our solution. So in our solution, we are given x squared plus px plus q is equal to 0. If we compare this with ax squared plus bx, okay, then plus c is equal to 0, we are going to realize, okay, we are going to realize that a is equal to, okay, a is equal to 1, b is equal to p, and then c is equal to, if you can see very well, c is equal to q. Okay, so sum of root, the sum of the new roots, that is alpha plus beta. So now, Mr. Examiner, sir, alpha plus beta, the sum of roots, not even new roots, but sum of roots, is going to be negative b, okay, which is p, over a, which is 1. Let us write this way. So this is a negative p. That is the sum of roots. Then what about alpha beta? The product of roots is equivalent to c over a. So c is q, a is 1. So product of roots is equal to q. Are we together, dear viewers? Okay. So what does the examiner want us to simplify? After getting alpha plus beta, alpha beta, in terms of p and q, we know very well that if we get this expression, try to expand it. We shall be focusing at creating alpha plus beta, and then alpha beta, we substitute them with p and q and obtain an expression required by the examiner. So we shall come and say that this implies that, Mr. Examiner, sir, our alpha minus beta squared, we are extracting this expression, then into beta minus alpha squared is now going to be the same as, if we try to expand this, it is going to give us alpha beta, okay, or we can put it on a new line, okay. We can say that this is equivalent to alpha beta, okay, then minus alpha cubed, okay, minus beta cubed, okay, and then minus, or plus, it is a plus, plus alpha squared, beta squared. So the only difficulty is here on alpha cubed minus beta cubed. We can proceed. What we can see here, we know very well that alpha, if we can rearrange this, if we try to rearrange this, it will produce alpha beta minus alpha cubed minus beta cubed, then plus alpha beta brackets squared. We have factorized out the square. Here we have factorized out the negative, so this becomes a plus rather. And then we have an alpha beta as the first one. But we know very well that alpha cubed plus beta cubed, we got it some time back, and we got it from alpha plus beta brackets cubed, then minus 3 alpha beta into alpha plus beta. That's what we got. Is it okay? So we can come and substitute it here, or we can first find it here. Alpha plus beta, where is alpha plus beta? Alpha plus beta, we obtain it as negative p. So this is negative p power 3 minus 3 alpha beta is q, then into negative p. So negative p, already we know, Okay, multiplies with this negative to get a positive. So plus 3qp or pq. We can make it pq. We rearrange. So this is going to be 3pq. Very interesting. So we take it back to our expression. We say that this implies that our alpha minus beta squared into beta minus alpha squared is going to be the same as, remember you had alpha beta, which alpha beta is the same as q, okay? Then minus alpha cubed plus beta cubed, which we have obtained as negative p cubed plus 3pq, okay? Then what else? Plus alpha beta squared. So plus alpha beta is the same as q. So q squared. So that is our stand. Allow me wrap off this. Hope you have already copied it in your books. So let us wrap it. Our body is very small. It cannot accommodate the math of NFO. Okay. So people who have sponsors there, we are looking for sponsors to sponsor our project. So if you have sponsors, people who can push money, inject money, invest into us, we are very ready to welcome them. So let us go and simplify. So this simplifies to alpha minus beta cubed into beta minus alpha squared is equal to, so if you try to simplify, you realize that this one becomes a positive p cubed. So let us start with the maximum power. But not forgetting what the examiner wanted us to prove. What he wanted us to prove, if you can recall it, it was p cubed, yes, plus q squared, plus q minus 3pq. Okay, so we are seeing it. We go with maximum powers. So this is plus p cubed, okay, then plus a q squared, exactly the way he wanted it, okay. Then plus q, yeah, that one was also there. You go and rewind your DVD, plus q, then minus, this minus is affecting that, minus 3pq, okay. However, I was equating that to 0, which means this expression has to come to 0. So therefore, this is the expression he first wanted us to prove, to find out. So can we prove that p cubed plus q squared plus q minus 3pq is equal to 0 if one root is the square of the other? Oh, that is very important. So for one root, let that root be alpha, equivalent now to the square of the other root, that is b squared. This implies that the whole expression alpha minus beta squared into beta minus alpha squared will now become, where there is alpha we are putting beta squared, so beta squared minus beta squared into beta minus beta power 4. But now we are going to realize that beta, okay, squared minus beta squared is 0, and this is a product, is going to make the whole product 0. So this is equal to 0. But remember, the whole of this was equivalent to that. So this implies that a p cubed plus a q squared plus a q minus a 3pq is equal to 0. So we can put this symbol. This mathematical symbol is the end of the proof. End of a proof. Or you can put the EQD. Yes. Or this is end of proof, or as required. We read this as required. Or you can put EQD, which shows the end of a particular proof. So I hope this is enough for you. For the roots and product of the, for the sum and product of the roots of a quadratic equation. Immediately after a break, let us get trial numbers. Numbers for you to try. Yeah. We'll be back from the break. Hope you are prepared now for your assignment. Yes, I want to read for you through such that those who are not familiar with my handwriting, you can get to know what I've written on the board. So number 1, given that alpha and beta are roots of the quadratic equation ax squared plus bx plus c. Oh, this is an equation. Okay, is equal to 0. It can't be an equation if it is not equivalent to 0. So we can say this is equivalent to 0 using black ink. Determine an equation whose roots are alpha plus beta and alpha cubed plus beta cubed. Hence or otherwise solve the equations. Okay. Number 2. If the roots of the equation x squared plus 2x plus 3 is equal to 0 are alpha and beta, form the equation whose roots are alpha squared minus beta and beta squared minus alpha. Okay. Number 3. Given that the roots of the equation x squared minus 2x plus 10 is equal to 0 are alpha and beta. Okay, alpha and beta, comma, determine the equation whose roots are 1 over, open brackets, plus 2 plus alpha, close brackets, squared, and 1 over 2 plus beta, in brackets, then squared. Then number 4, if alpha and beta are the roots of the equation x squared plus px plus q is equal to 0, find the equation whose roots are alpha cubed minus 1 over alpha and beta cubed minus 1 over beta. Then number 5, show that when the quadratic expressions x squared plus bx plus c is equal to 0 and x squared plus px plus q is equal to 0 have a common root, then c minus q into brackets squared is equal to b minus p into brackets cp minus bq into brackets. So this is a proof number. So immediately after a break, I'm going to use red ink to indicate for you the answers. Okay, so work out. Don't play this video before you have finished up to number 5. When you have finished up to number 5, then you play, and then you will see my session when I've indicated for you the answers for those questions which have answers. So immediately after the break, you'll find the answers. Yes, dear viewers, I've tried to insert the answers. Yes, I've worked out and I'm getting alpha is equal to -1 or alpha is equal to 3. Then beta is equal to -1 or beta is equal to 3. Those are when I solve the equations. However, I've not determined the equations. The equation I've not put them for you, but once you reach here, you will know that whether the equations you got are correct or wrong. So number 2, x squared plus 2 is equal to 0. That is the answer. Number 3, 3 to 4, x squared plus 1 is equal to 0 is the answer. Then number 4, qx squared minus brackets p squared q minus 2q squared minus p brackets x, then plus brackets q cubed minus p cubed plus 3pq brackets, then plus 1 is equal to 0 is the required equation. It's kind of lengthy for part 4, for number 4. Then number 5 is a proof. Once you get out to this, then it means you have got out the correct answer. So this has been the sum and product of the roots of a quadratic equation. So our major concern, our next concern is going to be the remainder theory, remainder and factor theory. So go and read about remainder and factor theory. Don't forget to like our social media platforms. That is the YouTube channel. Go there, watch, like, and then share our videos. We want the public to get to know us. Our YouTube channel is Wakata Online Study Classes. and then our Facebook page, Wakata Online Study Classes, or Wakiso Kampala Teachers Association. For any queries, call the numbers in this DVD. See you in the next